Alright, hi guys, welcome to a new topic on the turning effect of a force. Okay, I'm sure you learned in primary school before regarding the turning effect, or also known as the levers. Okay, and also, I'm sure also you, in the course of your life, you've probably built some Lego motorized vehicles or even some remote control cars, and you probably tried fixing things on your own. No? You in a corner. Yes. What have you done? Oh, okay, very good. So you've done your own DIY IKEA furniture. Wow, that's cool. Okay. So in those DIY IKEA furniture, what do you have? You have those bolts and nuts. So when you tighten a bolt, how do you tighten a bolt? Do you actually apply the force all the way in the center? Okay, not really, because if you apply a force all the way in the center, there's no lever arm, so no turning effect over here. Okay, so what you will do is you will have you use the spanner supplied and grab it one end, the other end of the bolt, the other end of the spanner rather, you will turn it. So you apply a force at the other end, and thereby you create this thing called a lever arm. Okay, so this one you actually have a maximum turning effect. Okay. Okay, so what is the moment of a force? Alright, so a moment of a force, also known as the turning effect, comprises of two things. First, it comprises of the force. Second, it comprises of the lever arm. Okay, so in other words, this is the formula. Moment of force is just force times the lever arm distance. Okay, so what is the lever arm? We'll go into that in the next slide, but before that, just to show what it means here, if I were to increase, I want to increase the turning effect. Let's say you want to tighten the bolt tighter. Two ways you can make it. You can increase the turning effect. One is you increase the force here. The other one, you increase the lever arm. You can see this is a much longer spanner, although with a smaller force here, right? Okay. So you can see here, right? Okay. So the next one is, what is a lever arm? Okay. So a lever arm was basically, you can see here, I have a force that's being applied to a spanner. At the other end is a bolt. Okay. So the lever arm is defined as the, what is that? As the perpendicular distance, right? Okay. So perpendicular distance from where? From pivot point to the line of action of the force. Wow, quite a few words here. Okay, so from the perpendicular, from the force, you can see there's a pivot point. So pivot point is basically the point that the whole mechanism rotates. The point doesn't really move, it basically just rotates about this point. What is line of action of the force? Okay, you can see the force is being applied here. And this line, if I were to extend the line, you can see the dotted line goes all the way. All right. And if I were to go this line all the way, there is only one distance here that gives me this thing called the perpendicular distance. You can see here, this perpendicular distance. So this perpendicular distance is known as my lever arm distance. Okay. All right. So you can see as I move my spanner, you can see if I rotate it tighter, as I move it tighter, what do you notice about my lever arm? Yes, you're right. It becomes smaller and smaller, right? Can you see? So if I want to move it the other way, it becomes bigger and bigger. Of course, with all along, I keep the direction of my force the same. So if I want to move down, you can see the lever arm actually gets smaller, becomes bigger. And when is it maximum? It's maximum when my spanner is actually perpendicular to the direction of the force. Okay, so this one will have maximum turning effect, in other words, because I have maximum lever arm distance, and I will have minimum turning effect when, let's see, whoa, I go all the way under here. What's my lever arm distance right now? You are right, it's now 0. Okay, so if I were to tighten the bolt, I apply a force along the spanner, whether it's a push or pull force, you can see there's 0 lever arm distance, so the effect is that there's 0 turning effect. Makes sense, right? Okay, of course, when you apply a spanner, you don't push or pull it, right? You actually turn it at a perpendicular direction. Okay, so just to make show another example of what lever arm distance mean in this case, um, just now my force, I was able to fix it. Now moving my force in if I want to change the direction of my force, look at how my lever arm, the distance actually changed. Check it out. Can you see what is happening now? Yes, as I move my force to make it more perpendicular to my lever arm, you can see my lever arm distance, this blue line here, actually starts to increase until the maximum of over here. You can see this is my maximum distance. In other words, this, if I were to apply a spanner in the perpendicular, the force, the perpendicular direction to the spanner, I get maximum turning effect. Okay, so if I would just like I mentioned, if I want to move it down to tighten or even to unscrew a bolt, so if I were to push it, you can see any lever arm distance here, zero, right? So by pushing the spanner down, you're not going to have any turning effect. Okay, the converse is also true. The other end, let's see, boom. Okay, can you see if I were to pull the spanner out, will it cause the bolt to actually turn? Not at all, right? Okay, so just to finish it up, so making the most of the moment to make the moment or the turning effect as large as possible, we must always apply our force as far away from the pivot as possible, and the distance must always, or rather, and the angle must always be perpendicular to my spanner. You can see, so this is how you screw or unscrew a bolt. Okay. So just to recap, okay, so here's what we covered so far. How do you define the moment of a force? Moment of force simply is just the product of force F to the perpendicular distance from pivot to the line of action of the force. In other words, I got a force F here. Let's say this is my door. This black line here is my door. I got a pivot here. This is my hinge. I turn the door in this way. Now to apply a force F, okay, to get the moment of the force, I don't just multiply the force times the distance from one end to the other end. I must make sure that distance is the perpendicular distance from where? From the pivot to the line of action of the force. So my force, although you only see is here, but the line of action stretches all the way, okay? So you can see even from my force over here, this distance, you can see this doesn't give me 90 degrees, okay? Only this gives me 90 degrees. So this will be my lever arm distance, okay? All right, so in symbols, moment of force is just force times distance, force in newtons, distance in meters, okay? And moment, as you can see, is a vector quantity, okay? Why? Because it doesn't just have a magnitude, but it also has a direction. Because in this case, let's say I have a pivot on the left. If I were to push a force up, you can see the whole thing will rotate in an anti-clockwise direction, right? Because this left end doesn't move, this right end moves, so the whole thing will move up. Okay, just like imagine this is a bolt. I'm actually unscrewing that bolt. Okay, but over here I have a bolt here. I'm actually moving a force downwards. I'm actually going in a clockwise direction. In this case, will be screwing the bolts. Okay, so hope you enjoyed today's sharing. All right, catch you in the next video.